Uh, so clear the hello. Yeah. So
Yes, sir. Yes, sir.
this is how S is equal to P plus JQ BI conjugate, and from where these equations are coming. So the most important part here would be about understanding. Do you know about the slack bus, load bus, regulated bus?
Yes,
Huh?
sir.
Yeah. What is a slack bus? Can you tell me?
Sir, it's those. Uh, right, then,
Or should I explain you?
yes, sir, I think it's very expensive.
A little bit you should understand now because you might have forgotten that part. Okay. So how to, that clear whiteboard option is not clear. Okay. Captions whiteboard. So whiteboard clear whiteboard option where it went. Yeah. Sometimes this zoom also not too much. Yeah. Wait one second. I'll reshare to you. Don't worry. Now it came clear. Yeah. So if you look at the screen over here, so in the power flow solution, we have certain concept called as power flow solution. What we need, what are the things that are involved? One is your voltage is involved. Okay. So
Yes,
if you
sir.
look at your power equation, it would be EV x into sine delta. That is the power that is produced inside the generator. Okay. This is the
Okay,
power
sir.
it is produced. Normal power is like single phase is VI cos phi, but the power that is produced within the generator has this formula. Okay. So
Okay, sir.
that you must have seen in your notes also, it is there, right?
Yes, sir. Yes, sir.
Yeah, so this formula also I'll explain, no issue. So power flow studies are known as the load flow studies basically. Okay. Load
Okay.
flow studies. And whenever we have to do any analysis of power systems, we look at this study for the planning and for economic scheduling of the power system. Economic scheduling would mean like how much hour there is the generation and the demand. Based upon that, where should we trip, where should we bill more?
Yeah.
Okay, like
Yeah. Right.
that means the economic scheduling. And control of an existing system, and control and planning, control of existing system, and planning for future expansion, and planning
Yes, sir.
for future expansion. Now, one important term associated with this is that future expansion. How do we go about this? How do our systems know yaar, ki how what are the variables that are associated with? So this problem will be determined by the magnitude and phase angles of voltage at each bus. So voltage will have some magnitude, okay, the value of the voltage, and it will have a phase angle. So this phase
Okay.
angle of the voltage is very important. And the further term, see, magnitude of voltage is there, then there is phase angle, then you have two more parts, that is the active power P, active power P, and then you have one more term called as the reactive power Q, reactive power. So these are the terms that are essentially involved with. So how to identify these terms? So what we require is that to identify these terms, we require some buses. The number one bus is called the slack bus. This slack bus is also known as reference bus. Okay, in some books it's also written as the datum bus. Okay, so this is
Okay.
very important bus. Now also known as swing bus. So not datum, swing bus. I just forgot. I was like thinking about the datum node. It is called as slack or swing bus. So this bus is basically taken as a reference. This is taken as a reference where the magnitude and where the magnitude magnitude and phase angle phase angle of the voltage are specified. The voltage are specified. So this is so here there are two quantities that are specified. One is your voltage and another is your phase angle. Okay, this angle is specified. This is the bus that makes the difference between the scheduled loads and the generated power. What are the loads you have and the power that are generated? So it will give you the various losses in the network. Okay, so this is very important. Bus, I'll write down this bus makes up. Actually, I'm teaching in the college now, and taking two
Yes, sir.
classes at a time becomes very. This bus makes, but you are having exams, so no issues. We'll manage. My schedule is now little light from tomorrow onwards, so I'm
Okay, sir.
wound up in our college. So this some so excuse me, pardon me. Sometimes I mean to say something, something else comes out. Okay, so I
Okay,
think
sir.
you will manage. You understand what I'm meaning, na? Sometimes
Yes,
you
sir. Yes,
like,
sir.
yeah. So it happens because you become tired at times. This bus makes up for the difference between the scheduled loads and the and generated power that are caused by the losses in the network. Okay. Uh, Ronil, are you understanding the subject? Like, do you like my teaching?
Yes, sir. Yes, sir.
Okay,
I
okay,
am.
okay, okay, yeah. So then there is after the slack bus there are three buses. One bus is called slack bus. Another bus we have is the load bus. So when we are talking
Okay.
about the load bus, every bus is having some or the other quantity. Like we are having four quantities primarily. One is your voltage, one is your phase angle, one is your active power, one is your reactive power. When considering about the slack bus, we are interested with voltage and the phase angle. What and it tells us the difference between the actual power generated and the scheduled load. Okay, this power is governing that part. Then there's another part which is called the load bus. So load bus will take into account the active and the reactive power. So this bus is also called as the PQ bus. Okay. So at
Okay.
this bus, the active and reactive power are specified. So at
Okay.
this bus, the active and reactive power are specified. And what happens with this bus is the magnitude and phase angle part of the bus voltages are unknown. Okay, we don't consider them. So these buses are called as PQ buses. Then there is regulated buses. Okay, or these
Yes, sir.
regulated buses or generator buses. Can you tell me what they do? Regulated buses or generator? You have taken down, na?
Yes, sir. Yes, sir. Yes, sir. I've taken note of it.
Yeah. So can you tell me regarding the regulated buses? What do they do? So I will clear this. Clear it.
Yes, sir. Yes, sir. Clear it,
Yeah.
sir.
So yeah. So can you tell me what the regulated buses or the generated buses will do? Hmm?
So help in power regulation.
No, not help in power regulation. Like what are the four values associated? Active
Okay.
power, reactive power.
Okay. Active power, reactive power. Yeah.
So voltage and angle was done with the help of voltage and angle was done with the help of slack bus. What does the slack bus do? It tells us the difference
One second,
between
sir.
the
One second.
generation and the schedule. And what about the
One.
load bus? Load bus is PQ. Now what is left? Now there are two more quantities left. See, left there is nothing left. There is voltage and power is left. See, we did
Correct.
voltage and angle. So this bus is called as PV bus.
Sir, voltage and angle is done by slack bus, right?
Voltage and angle is slack bus. This is a regulated bus. This is called as regulated bus. These buses are the generator. These buses are the generator buses. These buses are the generator buses, and they are also known as voltage controlled. They are also as voltage known as voltage controlled buses. Voltage controlled buses. So these voltage controlled buses, what do they do is that the real power and voltage magnitude are specified. So at these buses you can see P is the real power. At these buses, the real power basically, that is P, and voltage magnitudes are specified. Magnitudes are specified. So these are also known as PV buses. Okay. So slack bus. So this is your PV bus or generator bus. Okay. Then you have a load bus, which is known as PQ bus. PQ bus. Then you have a slack bus. Hello, Pronil, are you there?
Yes, sir. Yes,
Slack,
yes, sir. Yes, sir.
slack bus. This is voltage and angle bus. So
Yes, sir.
this is how these buses are explained. Now the thing is that now I will show you one iteration technique if the time will permit. So I have a technique called as, can I rub this? I'll I'll I'll
Sir,
uh, okay. Can I rub this? Okay, I will write
um,
here. No
so
issue. I
one
will write.
second, sir.
No issue. I think we are left with the, how much time is left?
Sir,
Uh,
2.5 minutes, sir.
yeah, let me write this Gauss Seidel method little bit so you should get an explanation. Suppose I have a non-linear equation f of x is equal to 0. So this is a non-linear equation. Now see, now you know the values of C. When you remember all these values, now tomorrow you should know power flow equation. Okay, power flow
Okay,
equation 100% you should revise it and come. And you should know
okay,
those equations what I have written, y bus, I bus and all. Then directly we are going to apply in these methods and we are going to solve the question paper which has come in your exam.
okay.
Because
Yes, sir.
if these basics are not known, I am explaining, you will tell sir how this came, how that came, then it will become problem for me.
Okay,
Okay.
okay.
I felt maybe that you don't know because when I talked to you yesterday, I felt that your basics are not there.
Yes, sir. Yes, sir.
Whether I was right or wrong.
Sir, right, right, sir. Right.
Right now, these things you are not knowing, so you are getting a little bit tensed. Huh? Because it is not
Yes, sir.
normally, because it's in a matrix form and matrix has been arranged, it has been predefined. And these matrices are now you should remember these matrices and directly you have to put in the equation and directly you will come. Okay, you are doing it
Got,
like
sir.
KVL, KCL, like that you are doing. No, it is not like that.
Yes, sir.
Okay, it is a different
Okay,
it is a different technique. So let's take this function f of x is equal to 0, and this function can be rearranged. Like, see, what we will do is rearrange this function as, I'll write this function in terms of x is equal to g of x. So what I do is that I take an initial value x of k, and in and x of k is an initial estimate. Suppose I'm getting an initial estimate, I'll do x of k of variable x, and then I want to I want to do iteration. If x of k I'm getting some value, what would be the my next value? X of k plus 1. Similarly, what would be my x of k plus 2? So if I'm doing two iterations, I'll say two iterations. I've done two iterations. So x of k plus 1, see, would be equal to g of x of k, because this was x is equal to g of x, x of k plus 1 term would be